Hey everybody, just wanted to really quick put this video out for you guys here on Monday. We are really getting down to it now, guys. There are only 4 assignments left, including the 2 that are going to be associated with this particular video. Please, please, please make sure that you pay attention to this video if you're planning on going on past Algebra 2 mathematically. Some of the stuff that we talk about in here is going to be very important moving forward. Also, you really are going to have zero idea how to do the check your understanding unless you really catch how this Radian measure works. This is something that's completely new for you guys, so make sure that you pay really close attention to how this works. The video should not be super long. It's a little bit shorter than what we have been doing, but it has a lot of good information. All right. So first things first, we are getting a new type of measure that we're going to be dealing with. This thing is called a radian, and I'll explain what a radian is. First, I wanted to show you, remind you how degrees works. Um, Remember, we've got the radius of a circle here, and if we were to grab this point here and then work its way around the circle, um, well, I guess I can't rotate that one because the way I did this, but um, if we were to do that, um, it would take a full 360 degrees to go all the way around. Okay, so in other words, if we had rotated this one up to here, that would be 90 degrees that we had rotated. If we rotated 90 more, that would be 180 over here. 90 more would be 270 over to here, right here. And then if we were to continue around, we'd have 360 total degrees. Well, radians are a different way to um, measure circles, and radians are very interesting the way that they work. The way a radian works is it's based off the concept of the radius itself. So if we were to take this, and I'm going to copy this here, I'm going to flip it over like this. If you were able to take this particular radius length right here, and then you were able to rotate that radius around the circle, kind of wrap it around the circle, where this would come down like this. So instead of going straight up, it would end up wrapping around the circle, kind of like this. And somewhere up here it would end. I don't know exactly where, but somewhere up here. That particular amount of rotation you would have would be 1 radian. All right. Not degrees. We don't use degrees. So we don't use the degree symbol. We just say that would be 1 radian. If you were to continue to do that around the circle, what's kind of neat is if you put a second one right here, it would go to maybe about right here or so, and a third one would go to almost right here, and then you'd have a little piece. Well, the amount of radians that you have to get from here all the way around the circle over to here is exactly pi radians. It would, there's 1, right? 1 radian. And then we do it again, and there's 2. And then we do it again, and there's 3. And then this little tiny piece right here would be about 0.14 radians. So you'd end up with 3.14 radians, or pi radians. So all the way around the circle is exactly, if this is pi radians, all the way around the circle would be 2 pi radians. And that's going to be the distance from here around this circle, all the way around back to here, is going to be 2 pi radians. Okay. And of course, it doesn't matter how big the circle is. If the circle gets smaller, the radius gets smaller, but the distance around the circle is still going to be 2 pi radians. And sometimes we use the letters RAD to stand for radians. It's still going to be 2 pi radians around the circle. So it's kind of nice the way that that works. Um, Radians always has the pi in it, always. Uh, there's certain circumstances where you might not exactly see that with decimals, different things, but usually radians has pi in it. And degrees has, of course, degrees. So one of the things that we need to do is to be able to convert between these two. Now, luckily for us, when you're using a calculator to do certain, measures, um, they have radian modes on calculators. So, that kind of helps us out as well, and degree modes on calculators. So we'll talk about that in a little bit. But first it says, what is the radian measure at 180 degrees? All right, we kind of already did that. On a circle, if we rotated 180 degrees, that would bring us to here. But on this circle, using radians, 180 degrees over to here is going to be pi. So keep that in mind, that 180 degrees equals pi radians. Okay. What is the radian measure at 90 degrees? Well, let's think about that. If we only rotated 90 degrees, let me pick a different color. If we only rotated 90 degrees, that means, hey, stop right here. So this would be 90 degrees right here. Well, if it's one whole pi from here all the way over to here, well, how far is it from here stopping right there? Well, it's half a pi. And there's a few different ways we could write that, like half a pi, but it's actually easier to write it like this. This is pi over 2. All right. So that's how many radians that is from here to here. It's pi over 2. That's, anytime you take some number and divide it by 2, you're cutting that number in half. So this is 1/2 of 1 pi. All right. So the radian measure at 90 degrees is pi over 2. What is the radian measure at 270 degrees? Well, 270, use another color, green this time, I guess. We'll start here and we'll go all the way. There's 90, there's 90 more, there's 90 more. That's 270 degrees. So that's what this would be right here, 270 degrees. Well, with this one here, if this is a half a pi from here to there, and then another half a pi from here to there, and then another half a pi from here to there, that's basically 1.5 pi. But you guys know we don't use mixed fractions in upper math. That's just not what we do. So we generally write this as 3 over 2 pi, but the best way to write that would be 3 pi over 2. Okay, and so that's the radian measure that matches up with that. All right, 3 pi over 2. So here, the last two that we have on this page are really important, guys. It's how do we convert between the two? All right, how do we convert from degrees to radians, and how do we convert from radians to degrees? And what's really nice about these guys is it's actually really easy to convert between the two. One of the very first things that we wrote down here just a second ago is 180 equals pi. Okay, 180 degrees in degrees equals pi in radians. So if you have degrees and you want to turn it into radians, so let's say you had, for instance, 90 degrees, okay, and you wanted to turn this into radians, the main thing that you need to do is you need to somehow get pi into this. All right, the degree symbol itself is going to go away, but we need to get pi into this. So what we're going to do is we're going to times this by pi over 180 degrees. And the reason is, guys, can anybody tell me what this number is? All right, this is pi over 180 degrees. We said a minute ago that pi is 180 degrees. Pi radians is 180 degrees. So if this is 180 degrees and this is 180 degrees, this is 1. And we know multiplying a number times 1 doesn't really change the number. All right, all it does is kind of convert it. All right, so 90 times pi would be 90 pi over 180. And then you ask yourself, what number goes into 90 and 180? Well, I hope you can see that 90 goes into both. 90 goes into 90 once, and 90 goes into 180 twice. So this is really kind of like 1 pi over 2, which we know is pi over 2. And we said that before, that 90 degrees was, right here, 90 degrees is pi over 2. All right. So how do we convert back from radians to degrees? So doing degrees to radians is not too bad. You always multiply times pi over 180. All right. And then basically your degree symbols cancel each other out. That's why they go away. Well, how do we convert back? Well, converting back is actually very easy. Remember, guys, we said a minute ago that pi in radians is equal to 180 degrees. So if we have something like, let's say this 3 pi over 2, 3 pi over 2, all we have to do is replace this with 180, because again, we're saying pi equals 180 degrees. pi radians equals 180 degrees. So just replace that. So this is going to be 3 times 180 degrees over 2. And then we just take our calculator out very quickly. Do some quick math here. 3 times 180 gives us 540 divided by 2. And we get 270. 270 degrees. And again, we said that right up here. See that? What is the radian measure at 270 degrees? We said it was 3 pi over 2. So converting between degrees and radians is really not a big deal at all. Again, just a really quick review of what you do. If you want to go from degrees to radians, you multiply times pi over 180 degrees. All right? And what that basically gives you is a fraction with pi in it, and then you simplify that fraction as much as you can. How do we convert from radians to degrees? Take the pi out, put 180 in, and then just do your math. You know, this number times the 180 divided by the denominator. If it doesn't go in a whole number of times, just simplify it and you'd end up with fractional degrees. It's not a big deal. All right. So here's a few to practice on. So we'll do a couple together, and then if you want to pause the video and try to do a couple yourself, please do so. But first, they want us to convert 150 degrees into radians. All right. So again, to change degrees into radians, we take the degree measure and we multiply it times, pi, lost my ink, pi over 180. Okay. So my degrees are going to get knocked out. So it's 150 pi over 180 pi. I'm sorry, over 180. So what number goes into 150 and 180? Well, go ahead and knock the zeros off. That makes that easy. So it's 15 pi over 18. And what number goes into 15 and 18? I hope you guys know that 3 does. 3 goes into 15 5 times. And 3 goes into 18 6 times. So this is 5 pi over 6. That is the radian measure that is equal to 150 degrees. All right. Well, what about convert negative 3 pi over 4 into degrees? Remember, all this negative right here means is that our rotation was clockwise, okay? When we have our unit circle and we rotate in a clockwise manner, that is a negative direction, all right? So we know that this right here is 150. That's positive, so that would be a counterclockwise rotation. All right, so we know our answer is going to end up being negative. We don't even really need to think about that. So just pay attention to this. So how do we convert radians into degrees? Well, we take our pi and we are just going to take this number right here and we are going to replace it with 180. All right. So we get our calculator out. It's going to be 3 times 180, which gives us 540. We divide that by 4. We end up with 135 degrees. So a negative 3 pi over 4 radians is negative 135 degrees. So in other words, start over here and rotate 135 degrees in the counterclockwise direction, which should end up somewhere, about right here, something like that. Okay? So why don't you guys take a look at these two. Pause the video if you want to try to figure them out on your own. If you're still confused, kind of watch how I do this. It's not that big of a deal. All right, so here we go. We're going to convert this degrees into radians. So negative 225 degrees times pi over 180 degrees. Our degrees gets knocked out. Again, you can kind of ignore the negative if you want, but so we get 225 pi over 180, all right? So now you just have to look at these two numbers and try to figure out what number goes into both of those. 5 definitely goes into both. Now there might be a bigger number, but we'll figure it out. I think probably 15 will go into both too, but 225 divided by 5 gives us 45 pi over, and 180 divided by 5 is going to be 36 And remember, this whole thing's negative when we started. What number still goes into both of those? I think you guys can see that 3 goes into both of those. All right. So actually, hold on. 9 goes into both of those too. 9 goes into 45 um, 5 times. So negative 5. Oof, my thing is messing up here. Negative 5 pi. And 9 goes into this 4 times. So we get negative 5 pi over 4 radians. And again, if you want to write RAD, you can. But it's generally understood that when you see this pi symbol, you're talking about radians. All right. And then converting 7 pi over 6 radians into degrees. Remember, guys, all we're going to do is we're going to take this pi symbol and we are going to replace it with 180 degrees. And again, just a reminder of why that is. When we went back to our first screen, you guys know that this is 180 degrees here. This is also pi radians here. These two things are equal to each other. Okay. All right. So 7 times 180. 7 times 180 is 1,260 divided by 6. And that is 210 degrees. All right. So that is how to convert between radians and degrees and radians. It's pretty simple. All right, guys. All right. So they want us to do this problem right here. Here's the example that they're giving us. And let's see what information they want. Well, they want us to tell them what is the sine of pi over 6, what is the cosine of pi over 6, and then what are the coordinates of point A. All right. So this goes back to, if you remember, there was a little chart that we had about the quadrants. And at the beginning, we talked about what sine is and what cosine is and all that other stuff. Let me kind of remind you how that works. So remember, when we're talking about sine, we know that sine is opposite over hypotenuse. Now remember, the hypotenuse is going to be a 1 right here. That's what that's going to always be in a unit circle. And from this angle right here, we know that the opposite side is over here. So this is the opposite side. Now, let me write opposite so that doesn't look like it's 0 because we know it's not 0. And this right here is going to be what we call the adjacent side. And when we do a cosine problem, we know that that is adjacent over hypotenuse. Well, I want you to think about this. If you're going to take this problem here and you're going to do opposite over hypotenuse, well, if you put opposite over 1, right, opposite over 1, you're just going to get opposite, okay? And on this one here, if you put adjacent over 1, okay, you're just going to get adjacent because any number over 1 is just itself, all right? And remember, the unit circle is on a graph. Here is the origin, all right? Here is 1. Here is 1, right? And this point right here, the coordinates of this point are going to be however far it is from here to here and however far it is from here to here. So this is going to be an x and this is going to be a y. So look, adjacent is the x, opposite is the y. And so when you're talking about sine, you're talking about y. When you're talking about cosine, you're talking about x. All right. So when they say find out what is the sine of pi over 6, they're just asking you what is the y. All right. And then when they say find cosine of pi over x, they're just asking you what is the x. All right. And when they say find the coordinates of this point here, point A, it's going to be these two values that we have here. Whatever is here is going to be here, and whatever is here is going to be there. All right. So that's all the stuff that they're talking about. So just remember, an easy way to remember this, sine in the unit circle is always y. Cosine in the unit circle is always x. All right. Always, 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 always. So just kind of keep that in mind as you're doing these. So let's go ahead and figure out what this is. So evaluate sine of pi over 6. So they're asking us what is the, what is this going to be right here? Remember, sine is y. So what you want to do here, guys, is you want to take and you want to think about those special right triangles that we were dealing with before, 45, 45, 90, 30, 60, 90. And we want to see what this angle measure here is. So we know to convert this in degrees, all we're going to do is we're going to take this pi and we're going to turn it into 180. So on our calculator, we're going to do 180 divided by 6, and we get 30 degrees. So we know this angle right here is a 30-degree angle. So if that's a 30-degree angle, that means this is a 60-degree angle, because we know for a fact that this is a 90-degree angle, all right? And what we've got here is a 30, 60, 90 triangle. Now, I know it doesn't look like one, but they always get away with that by saying this drawing is not drawn to scale. So what we're going to say is we know that the unit circle always, always, always has a hypotenuse of 1. The side across from the 30-degree angle is always 1/2 the length of that, which is 1/2. And then the side across from the 60 is always the square root of 3 over 2. Always, always, always in a 30, 60, 90 triangle in the unit circle. So what that means is, what is our y? What is our sine of pi over 6? Well, that is this 1/2 right here. So this is 1/2. And one of the reasons why this is positive, or the reason why this is positive, is because we are moving to the right and we're moving up. So when we move up, that's positive. Well, what about our cosine of pi over 6? Well, remember, cosine is the x. So what is the x value from here over to here? Well, that is square root of 3 over 2. And again, that's positive because we are moving to the right. So square root of 3 over 2. And what would that make our coordinates? Well, if you start at the origin, you move right this much, and then you move up this much, your coordinates right here are going to be square root of 3 over 2, comma, 1/2. And that is going to be the answer that we would put for the, determining the coordinates of A. All right. So again, just remember, sine is y, cosine is x. This is the way it is in all of these unit circle problems. Okay. So here is an example of a unit circle that has some pieces missing, and it's really about converting between the two. So, I'll show you a few of these and then I'll show you the finished product at the end. I'll kind of speed through it a little bit. And then we'll talk about very specific areas on this and the way that it works. But I'm not going to bore you by having you just watch me convert every single one of these. But just remember, on the outside are the degree measures, on the inside are all the radian measures, and we're going to match them all up. Okay. Now, remember, whenever we're going from the uh, radian measures to the degree measures, we are going to take and replace this pi with 180 and then just do the math. So, for instance, we'd put 180 here and divide it by 6, which we did just a few minutes ago, and that would make this a 30-degree angle right here, starting from here and then rotating our terminal side up to here. That would be 30 degrees. Whenever we go the other direction, so for instance, this 45 degrees, if we wanted to change it into a radian measure, we would take the 45 degrees and we're going to times it by 180. I'm sorry. If we wanted to convert this 45 degrees right here, we would take this 45 degrees and we would multiply it times pi over 180. So our degrees get knocked out, and then we ask ourselves what number goes into 45 and 180. And I hope you guys recognize that 45 goes into 45 and 180, because we know for a fact 45 goes into 90, and 90 definitely goes into 180. So 45 goes into 45 one time. That would be 1 pi on the top, but that would be silly to write 1 pi, so we're just going to write pi. And then 45 goes into 180. Well, 45 goes into 90 twice, and there's two 90s in 180, so it goes in 4 times, so this is pi over 4. Okay? And then you would just convert these all the way around. So we know for a fact that this is 90 degrees, and this is 180 degrees, just filling in some of the ones that we know for sure. Hopefully you guys know that this is 270 degrees. Here's a weird one over here. This is 0 degrees, and at the same time, it's also 360 degrees. And then the other ones we can just, fill in here and there. So I'll just do a little bit here. So pi over 3, that would be 180 over 3. All right, this is 180 over 3. So 180 divided by 3 is 60 degrees. Over here, this is 2 times 180. So 2
times 180 over 3. Well, 2 times 180 is 360. So 360 divided by 3 is 120. 120 degrees. Let's see as we go. So this is converting degrees into radians. So we're going to do 135 degrees times pi over 180 degrees. Cancel, cancel. So 135 pi over 180. Right? And again, 45 goes into both of these. 45 goes into 135 3 times. And 45 goes into 180 4 times. So this is 3 pi over 4. Or another way to think about that is 3/4 of a pi. Okay? So this right here, 5 times 180 divided by 6. 5 times 180 divided by 6. 5 times 180 divided by 6. 150. Alright, down here, 7 times 180. I really should be using the degree symbol. Over 6. So 7 times 180 divided by 6. 210. Converting degrees into radians, again, 225 times pi over 180. Cancel, cancel. That's 225 pi over 180. Let's see, I believe 45 still does go into that. So 225 divided by 45 is 5, so this is 5/4 of a pi. 5 pi over 4. And then this right here, 4 pi over 3, so this can be 4 times 180 over 3. So 4 times 180 is 720. Oops, 4 times 180. Divided by 3. 240 degrees. On the other side, we're doing 5 pi over 3, converting into degrees. So again, this right here, we're going to take 180 and put it right there. So 5 times 180 divided by 3. 300 degrees. 300 degrees. And then 315 over to here. So we're going to do 315 degrees times pi over 180. Cancel, cancel. 315 pi over 180. Again, I believe 45 goes into that one more time. So 45 into 315. 315 divided by 45 is 7. And we already know that 45 goes into 180 4 times. So that's 7 pi over 4. And then finally, the last one we have to do is 11 pi over 6 radians converted into degrees. So 11 pi, we're going to just change this here to 180. Okay, so we got 11 times 180.
which is 1,980, and then we're dividing that by 6. We end up with 330 degrees. So that is a completed unit circle with all of the angle degrees in our angle measures in degrees and radians. The only thing that we don't have, and I'll show you a picture of in a minute, is the coordinates at each of those points. So you can see those in a unit circle in just a minute. All right. So that should be the end of the the first part. So you should be able to do the check your understanding questions for section 13, topic 3, which is the Radian Measure part 1 on algebra nation. Please, guys, again, try to make sure that your first attempt is a valid attempt. Don't just guess your way through the first time in a minute or so and then see what the correct answers, and then, try to do, and try to cheat your way through it. You really want to understand how these radians work, especially if you're going to move on to math after Algebra 2. All right, now, part 2. Part 2 is all about what about the other 3 quadrants. If you haven't noticed, most of the work that we did when we found sine and cosine, we dealt mainly in quadrant 1. What we're going to be doing now is we're going to be working in the other quadrants as well. Also, there are some new trig ratios that we need to talk about. We don't use them very often, but you're going to see what they are, and you're going to see how they work and the reasons why we have them. But there are some new trig ratios besides sine, cosine, and tangent that we have to deal with. So first off, it says a reference angle is an acute angle formed by the terminal side of the given triangle and the x-axis. I'll explain this in just a second. So when we do some of this work on the unit circle, we have to draw a reference angle that we can then use to draw a reference triangle so that we can end up working in the unit circle in other parts of the circle. So it says reference triangles can be used to evaluate the trigonometric values of an angle whose terminal side is not in quadrant 1. So let me kind of explain how that works. All right. if we are working in quadrant 1, remember this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay. If we are working in quadrant 1, this is a very easy thing for us to do because as soon as we draw this terminal side, we can immediately draw ourselves a right triangle. All right. This is our x. This is our y. If we wanted to find the measure of angle theta, it's very simple. We know that this is 1, and then we can just figure out this in degrees or radians or whatever we need, and we can find this x or y very easily, as long as it's in quadrant 1. Well, what happens if it's not in quadrant 1? Well, if it's not in quadrant 1, like this terminal side is in quadrant 2. The problem with this is we can't make a right triangle that encompasses angle theta. Angle theta is greater than 90 degrees, all right? There's no way that we can draw a triangle that contains an angle greater than 90 degrees, because the right triangle has to have a 90-degree angle in it. So what we have to use is we have to use a reference triangle, right? And a reference angle. So what we're going to do instead is we are going to use the fact that we know that we can drop this down here to the x-axis over here. And if we know that this angle theta, what we're going to do is we're going to use this angle right here to help us out, all right? And then we can find out this x, and we can find out this y, and we can find out this x comma y, all right? All while using a different triangle and a different angle than the angle that we're actually trying to figure out, okay? So that's all we're talking about. The same thing over here. Now, you have to be a little bit careful, though. If you look up here, remember it says this reference angle is an angle formed by the terminal side of the given angle and the x-axis. So you do have to be extremely careful because this will give you some false answers. If I understand how a lot of students might do something like this, all right? But what they're doing is they're making a reference angle that is using the y-axis. We want to make our reference angle and our reference triangle always deal with the x-axis. We're talking about this thing right here. We always want to be dealing with this one here plus the terminal side, okay? And that way we know for a fact when we do that, that this angle here and this angle theta that we have, this huge angle theta, which is very big. It's bigger than 180, all right? It's even bigger than 270. We know that these two here go together to make 360 degrees or 2 pi radians completely. So we can use this measure to help us out find this, help us find out this measure here, all right? So that's how that works. So here's an example. So it says, consider the unit circle diagram below. We've got 7 pi over 6. We know that this is a radian measure. And let's see what information they want from us. They, again, want the sine, they want the cosine, and they want the coordinates of C. All right. And, that's not too bad. What we want to do is, again, we can't make a right triangle that contains this angle. This is too big of an angle. So what we're going to do is we're going to use a reference angle, which is going to be this one right here, and a reference triangle, which is going to go, again, to the x-axis, all right? So we've enclosed this angle here inside of the triangle. So this is the angle that we're going to be dealing with right here, all right? So we know that when we're doing this 7 pi over 6, we're going to go ahead and convert this to degrees. Remember how we do this? We just replace this with 180. So we're going to get our calculator out. We're going to move this over here. We're going to do 7 times 180 divided by 6. And we get 210 degrees. Guys, we know for a fact that it's 210 degrees from here all the way over to here. 210 degrees. Now, if it's 210 degrees from there all the way over to there, and we know how many degrees is it from here to right here, stopping right here, that ends up giving us 180 degrees. So if we subtract those two, we get 30 degrees. So we know that this angle right here is 30 degrees. All right. With that information, we can find out the sine, the cosine, and the coordinates. All right. Remember, sine is always, always, always y on these unit circles. Cosine is always x. So the y would be this one, the x would be this one. Now, we are ending up over here in what we call quadrant 3. Now, I want you to think about, is x and y positive or negative over here? If you were on a graph, you went to the left and you went down, you ended up over here. You should know you're going to have a negative x and a negative y. All right. So now all we got to do is we got to figure out those values. How far did we go over? Remember, the hypotenuse is always going to be 1. The side across from the 30-degree angle is always going to be 1/2. But since we're over here, this is going to be negative, since we're down. And then the side across from the 60-degree angle is always going to be square root of 3 over 2. But again, it's going to be negative because we're moving to the left. So the sine of 7 pi over 6 is going to be negative, 1/2, because it is the y. Almost made a mistake there. Negative 1/2. Oops. All right. Negative 1/2. The cosine of 7 pi over 6 is going to be negative square root of 3 over 2. And the coordinates of that point are going to be, well, if you went negative 3 over 2 to the left, or negative square root of 3 over 2 to the left, and negative 1/2 down, the coordinates of this point right here is going to be negative square root of 3 over 2, comma, negative 1/2. There you go. All right. And so that would be the coordinates of point C. All right. So take a look at that one. See if you guys can do that one. All right. So we are trying to find the coordinates of point A. And this time we're doing sine, cosine, and tangent because that's going to help you see how the tangent works. All right, guys, remember when you do sine, what you're really finding is y. When you do cosine, what you're really finding is x. And we didn't talk about this one before, but tangent, just a quick reminder, here's your unit circle. And let's just stick in quadrant 1. Remember, this is 1, but tangent of this angle, the central angle, remember, tangent is opposite over adjacent. Okay, so this would be the opposite side, this would be the adjacent side. So this is going to be y over x, right? So if you were to work on this one and draw the reference angle and the reference triangle, the reference angle is here, the reference triangle is here. So we're dealing with this angle right here, this one right here. All right. So what we're going to do is we're going to, the cosine would be, of course, the y, that would be over here. The x would be, of course, right here, and we already know that this is going to be 1, right? So we're going to take this and we're going to convert this to degrees. So this pi turns into 180. So we get our calculator out, and we do 5 times 180, and then we divide that by 3, and we get 300. So that means if this angle right here is 300 degrees, that means this angle here has to be 60 degrees because a full circle we know is 360 degrees. So if this is 60, that makes this 30. If this is 30, that means this is the 1/2. Remember, the side that's across from the 30 is always 1/2 in a unit circle. That means this side, the side that's across from 60, is always, always, always square root of 3 over 2, right? But this is going right, so this is positive. This is going down, so this is negative. Okay, so far these are going to be actually really easy to find. So the sine of 5 pi over 3 is the y, so that is negative square root of 3 over 2. All right. The cosine of 5 pi over 3 is going to be the x, which we see as positive 1/2. The coordinates of A, we can go ahead and do that really quick. The coordinates of A, that would be this point right here. I guess it's not marked as A, but that's the point they're talking about. So if we go 1/2 to the right and then negative square root of 3 over 2 down, that would be 1/2, comma, negative square root of 3 over 2. And then finally, the tangent is a little bit weird. Remember, tangent is y over x. Well, put this over this. Now, this looks really weird, right? Square root of 3, or I'm sorry, negative square root of 3 over 2 over 1/2, right? Y over x. But remember, a fraction is division. So negative square root of 3 over 2 divided by 1/2. Now, remember when you divide fractions, what you do is you multiply the reciprocal. So this would be negative square root of 3 over 2 times 2 over 1. All right? And when you do this, a negative times a positive is a negative. And then square root of 3 times 2 is 2 square root of 3. And 2 times 1 is 2. And if you notice, those two cancel out. And you're just left with the negative square root of 3. And that is what the tangent would be, negative square root of 3. All right? Right, here's a similar one. See if you could do that one by yourself if you want to. Just really, I want you to pay really close attention, guys, to where are you drawing your reference triangle. All right, so we're going to be going from here straight down. This is the angle that we're going to deal with right here. Right, this is going to be our x, this is going to be our y. Now, if you want to go ahead and say, hey, guess what? I know my x is going to be negative because we're going to the left. I know my y is going to be positive because we're going up. So when we do find this coordinate right here, it's going to be a negative x and a positive y. All right. Remember, sine is the y. Okay. So again, you're going to replace this with 180. Right. So we take our calculator out. 3 times 180 is 540 divided by 4. We end up with 135. So this angle here is 135 degrees. Oops, 135 degrees. Now, if that angle is 135 degrees, we know all the way over to here is going to be 180. So if we do 180 minus 135, we find out that this angle is 45 degrees. All right. Now, what's nice about the 45, 45, 90 triangle, remember the hypotenuse is always 1. These two sides have to be the same as each other. Again, I know we're going to call one positive and one negative because of the directions they go, but their values need to be the same. So if you guys don't remember what those values are, they are the square root of 2 over 2. That's what it is all the time, every time. So these are both square root of 2 over 2. That's just what they are in the unit circle. Again, when you're not dealing with a unit circle, 45, 45, 90 triangles can have all kinds of measures. But when you are dealing with a unit circle, the legs are always going to be square root of 2 over 2. Now, of course, this is going to be negative. This is going to be positive. So this is going to be square root of 2 over 2 because this is the y. This is going to be the x, which is going to be negative square root of 2 over 2. And then, of course, the tangent is going to be the y over the x. Now, I hope you guys recognize what this ends up being. Look, it's the negative, I'm sorry, it's the square root of 2, it's y over x, y over x. So that's going to be square root of 2 over negative square root of 2 over 2. I just want you to think about that for just a second. I'm pretty sure you guys could figure out what this value is without doing any crazy math. We can do the crazy math version of it, but I hope you guys recognize that this is just going to be -1 because this is the same thing. This is one number over itself, except one's positive, one's negative. So it's the square root of 2 over 2. And I'm going to go ahead and change it to times and then flip this. So that's going to be -2 over the square root of 2 because I know what I'm dividing. I'm just going to flip. And so on the top, you get square root of 2, 2 square root of 2. I'll write it over here, 2 square root of 2. And on the bottom, you get 2 square root of 2. And then the whole thing's negative. And you guys know that's 1. So it's -1. All right. And then finally, the coordinates of B, again, you're just going to pick these out. They're right here. I mean, the x goes first, so that's negative square root of 2 over 2. The y goes next, that's square root of 2 over 2. And that is our coordinates of B. All right. Now, um, here we have the unit circle, and this is a actually fully kitted out, fully labeled unit circle with all the sines and all the cosines and all the tangents and all the, you've got all of the degree measures here in the very center, right here. You've got all the radian measures right here. And then on the outer layer here, what you have is you have the coordinates for all those points. And notice all of those points, except for, the points right here and here and here and here, which are all about ones and zeros. All of those points only consist of three different values: 1/2, square root of 3 over 2, and square root of 2 over 2. Okay, some positives, some negatives, but you'll never find any numbers out here that are different than those. All right. Remember, you use these two when you're dealing with 30, 60, 90 triangles, and you use this one when you're dealing with 45, 45, 90 triangles. Okay, and notice how anytime you have those, they're the same. Everybody see those, how they're exactly the same as each other. Um, where on these other ones, all that happens is these keep switching. All right, these keep switching is all that happens. Like this one and this one are the same, and this one and this one are the same. All right. Um, and it's the same thing here. This one and this one is just basically the flip of this one. Again, I'm kind of ignoring the positive negatives parts because I know for a fact you guys know everything in quadrant 1 is positive. Over here, the x is negative, but the y is positive. Over here, the x and the negative or x and the y are both negative. And over here, the x is positive, but the y is negative. I mean, you guys have known that for a long time on a graph. Now, there's one other thing that I need to introduce to you guys. All right. Technically, it's three things, but we've got some new trig ratios. All right. Luckily, they're not completely new. They're actually related to these. All right. We have the names of them here. All right. And I'll write them in. This one is called cosecant. All right. This one is called secant. And this one is called cotangent. And these are the abbreviations: COT, SEC, and CSC. Sometimes you'll see this one spelled out like COSEC. Um, but anyways, if you notice, each of these is related to one of the previous ones that you've learned. Take sine, turn it over, it turns into cosecant. Take cosine, turn it over, it turns into secant. Take tangent, turn it over, it turns into cotangent. So they're actually very, very easy to deal with, but I needed to go over with you guys these with you really quick because you're gonna see them in your check for understanding questions in this topic 4. All right, so you need to make sure you understand how those work. So again, just take a look at this here. I mean, it's very, very interesting how these all kind of like match up with each other and how this thing works. This is like 1/6 of a pi, 1/4 of a pi, 1/3 of a pi, 1/2 of a pi. We got 2/3 of a pi, 3/4 of a pi, 5/6 of a pi, one whole pi, right? 7/6 of a pi, which is a little bit more than one pi, 5/4 of a pi, 4/3 of a pi, 1.5 pi, if you really think about it. 3 pi over 2 is 1.5 pi. Then we got 5 pi, 5/3 of a pi, 7/4 of a pi, 11/6 of a pi. This is almost 2 pi's, right? 11/6. 12/6 would be 2 pi's. And when we do get over here, and for some reason they didn't put it, this over here is 2 pi. Okay. There is one little one they missed, but so this is all the way around the circle is 2 pi radians. Okay. So here's an example of what I was talking about. In your check your understanding question, you have a couple questions that look exactly like this. It says, let the point AB be on a circle if A comma B has a rotation of r degrees, then which of the following is not correct? And they want you to select all that apply. Well, first things first, make sure you understand they want you to select the things that are not correct. Now, as you start looking through the questions, all right, you're going to see sometimes they'll give you like a ratio like sine, all right? and it'll tell you sine of r equals, and you're going to say, well, that might be equal to a, right? Or sine of r is equal to negative a, right? Just remember, when you are rotating in a positive direction, these are positive. That means, and as far as I can tell, they're really only kind of, you don't have to worry about coming way over here, but it's mainly these two quadrants. But if you're rotating in a positive direction, that means this way, all right? If you're rotating in a negative direction, like let's say this is sine of negative r, that means you're rotating in a counterclockwise direction. So keep that in mind when you're doing these, and remember what sine is, all right? Sine is y, okay? So, and if this point over here, let's say right here is a comma b, which one of these is the y? Dot, 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 this one, right? So just keep that in mind as you're doing those questions. Again, if it does cosine, that's one thing. If it does tangent, that's a thing. If it does cotangent, remember tangent is y over x, so cotangent is x over y. All right. If sine is y, then cosecant is 1 over y. All right. All it does is it flips it over. So just keep that in mind when you're doing those check your understanding questions. They're a little bit involved. Just take your time, do your best on them. Just think about it as you're doing it. Think about when I'm moving counterclockwise or if I'm moving clockwise. Uh, remember this way is plus, positive, this way is minus, and make sure that what you're talking about over here is matching up with what's over here as far as like if you ended up down here, would you have a positive A or a negative A, right? If you were over here. Down here, the A would be positive, but the B would be negative because remember, this would be to the right and down. So this would be positive because we're moving to the right, while this would be negative because we're moving down. That's how those check your understanding questions work on this particular topic. All right, guys, so now you should be able to do the check your understanding questions for section 13, topic 4, the radian measure part 2. And again, guys, this is, you know, these two assignments here this week, and then the two assignments next week are your last two assignments. So, or the last set of your assignments. Your last video will be coming out next week, again, hopefully on Monday. And then the last week of school is more about just you catching up and taking care of anything that you didn't get taken care of yet. All right. So have yourselves a good week and a good weekend, and I'll see you next week. Thank you.